Here's a concise 10-minute read on carbon and its compounds for grade 10 students. 1. Introduction to carbon. Carbon is a non-metal element with atomic number 6. It is unique because it can form 4 bonds with other atoms, allowing it to create a vast variety of compounds. Carbon atoms can bond with other carbon atoms to form long chains and rings, which are the foundation of organic compounds. Forms of carbon. Diamond, a very hard crystalline form used in cutting tools. Graphite, a soft, slippery material used in pencils and lubricants. Amorphous carbon, found in charcoal, soot, and activated carbon. 2. Allotropes of carbon. Diamond. Each carbon atom is bonded to 4 other carbon atoms in a tetrahedral arrangement, creating a strong, rigid structure. Graphite. Carbon atoms form layers of hexagonal rings with weak forces between layers, allowing them to slide over each other, why graphite is slippery. Fullerenes, molecules made entirely of carbon, shaped like spheres or tubes. Example, Buckminster fullerene. A single layer of carbon atoms arranged in a hexagonal lattice with remarkable strength and conductivity. Shasha 3. Bonding in carbon compounds. Carbon can form bonds in different ways. Single bond, sharing 1 pair of electrons. Example, ethane, C2H6. Double bond, sharing 2 pairs of electrons. Example, ethene, CH4. Triple bond, sharing 3 pairs of electrons. Example, ethene, C2H2. These bonds allow carbon to form various structures like chains, rings, and networks. 4. Types of carbon compounds. Carbon compounds are divided into organic compounds, compounds containing carbon, and inorganic compounds, compounds where carbon is absent or exists in specific forms like carbonates, oxides. Organic compounds, these include hydrocarbons, compounds made only of carbon and hydrogen. Alkanes, saturated, example, methane, ester. Alkenes, unsaturated with 1 double bond, example, ethene, C2H4. Alkynes, unsaturated with 1 triple bond, example, ethyne, C2H2. Aromatics, compounds like benzene, C2H2 with a ring structure. Functional groups, groups of atoms that define the properties of a compound. Alcohol, OH group, example, methanol, CH3OH. Aldehyde, CO group, example, formaldehyde, HCHO. CO group, example, acetone, carboxylic acid, COOH group, example, acetic acid, CHCOOH. Ester, COO group, example, ethyl acetate, COOH2, CH3. Number 5. Properties of organic compounds. Boiling and melting points. Alkanes have lower boiling points than alkenes and alkynes. The presence of functional groups like alcohols can raise boiling points. Solubility. Organic compounds like alcohols are soluble in water because of their OH group. Hydrocarbons, on the other hand, are insoluble. Reactivity. The presence of functional groups determines the reactivity of organic compounds. For example, alcohols are more reactive than alkanes. 6. Combustion of carbon compounds. Complete combustion occurs when carbon compounds burn in excess oxygen to form carbon dioxide and water. Example, text CH for plus 2O2, CO2 plus 2H2O. Incomplete combustion occurs when oxygen is limited, leading to the production of carbon monoxide, CO and or soot. 2CH plus 3O2, 2CO plus 4H. Bar 7. Acids, bases, and salts in carbon compounds. Carboxylic acids, organic acids that contain the carboxyl group minus COOH. Example, acetic acid, CH3COOH in vinegar. Formed by the reaction between an alcohol and a carboxylic acid. Esters are responsible for the fragrance of fruits and flowers. Example, methyl acetate, CH3H3. 8. Industrial uses of carbon compounds. Fuels. Hydrocarbons like methane, propane, and butane are used as fuels. Plastics. Polymers like polyethylene and PVC are made from organic compounds. Pharmaceuticals. Many medicines are organic compounds that have specific functional groups for their action. 9. Environmental impact. Burning fossil fuels releases carbon dioxide, CO2, a greenhouse gas that contributes to global warming. Efforts are being made to find alternative sources of energy and reduce the environmental impact of carbon-based fuels. Conclusion. Carbon is the foundation of life on Earth, forming the basis for organic chemistry. Its versatile bonding abilities allow it to form millions of compounds, making it essential for life and industry. Understanding carbon and its compounds is crucial for grasping concepts in chemistry, biology, and environmental science. This quick overview of carbon and its compounds summarizes the key points students need to know for grade 10. You can use this as a revision tool or guide for further study.